من موضوعاتنا وهو موضوع the work. هنتعرف النهارده على الورك، هنعرف يعني ايه work ونعرف الريليشن بين الورك والفورس والديسبيسمنت. نشوف ازاي نقدر نحسب الورك لو كانت الفورس والديسبيسمنت فيكتورز او كان مديني الماجنتيودز بتاعت الفورس وبتاعت الديسبيسمنت. Dear students of grade 3 secondary, welcome to our math program. Today we have dynamics. Our lesson today is work. First, the work done by a constant force. Let a body move in a straight line under the action of a constant force, F vector, and it moves from position A to position B. And its displacement vector AB equals S. The work done by the constant force F to move a particle from an initial position to a final position and denoted by the symbol W is known as the scalar product of the force vector by the displacement vector between the two positions. Then W, the symbol of the work, equals vector F dot vector S. It's clear that the work is a scalar quantity that may be positive, negative, or equal 0, according to the magnitude and direction of both vectors, vector F and vector S. Let's start with the first example. A particle moves in a straight line under the action of the force F vector equals 6i plus 8j. 6 in the positive direction of x-axis and 8 in the positive direction of y-axis. From point A, 3, negative 4, to point B, 7, 2. Calculate the work done by this force. The force F act on the body to move it from the position A to position B. Now, what is the displacement from A to B? The displacement S equals vector AB, which equals vector B minus vector A. Vector B, the position vector of the point B, which equals 7, 2, minus vector A is the position vector of the point A, which equals 3 and negative 4. Then the vector S equals 4 and 6. Now, the work equals scalar product of vector F and vector S. W equals vector F dot vector S. Vector F equal 6, 8 dot vector S equals 4, 6. The work W equals 6 multiply 4, the first component multiply the first component, plus 8 times 6, the second component multiply the second component. Then work equals 24 plus 48, which equals 72 work unit. Now, dear students, some different cases of the vectors of the forces and displacement. The work done by a constant force in moving a particle from an initial position to a final position is defined as scalar quantity. Scalar product of the two vectors, force F and the displacement vector S. Then W equals vector F dot vector S, which is a scalar quantity. Now, if the force F inclined to the direction of motion by an angle of measure theta, or the direction of F is perpendicular to the direction of motion of the body, or the vector F inclines to the direction of motion by an angle of measure theta. And note that in the first case, theta is an acute angle, and the third case, theta is an obtuse angle. In the second case, theta is a right angle. Now we can use the definition of the scalar product and write the work W equals norm vector F multiply norm vector S cosine their included angle theta, where theta is the measure of the small angle between the two vectors F vector and S vector. Now, dear students, we must note that if 0 smaller than or equal theta smaller than or equal 90 degrees, then cosine theta bigger than 0, and the work in this case is positive. But if theta equals 90 degrees, then cosine theta equals 0, and the work in this case equal 0. And if 0 degrees smaller than theta smaller than or equal 180 degrees, then cosine theta less than 0, and the work in this case is negative. And when the work done is negative, we call it is a resisting work. And the work done by a force must be defined between two positions. One of them is initial position and the other is final position. If a body moves from a point and returns to the same point, then the work done by this force during the path is equal to 0, because the displacement of the body in this case equals 0, then the work equal 0. Now we have a very important rule. The rule says that if two subsequent displacements occur to a body under the action of a force, then the work done during the resultant displacement is equal to the sum of the work done during each of the two displacements. Then W equals W1 plus W2. And in general, for any finite number of consecutive displacements, then the resultant work W equals W1 plus W2 plus W3 plus dot till to Wn. Example, the force F vector equal 3I plus 5J acts on a body and moves from point A, 2 and 4 on a straight line to the point B, which equals 5, 3, then to point C, 8 and negative 2. Calculate the work done by this force during each of the two displacements. Then check if the sum of the two works is equal to the work done during the resultant displacement. First, what is the first displacement vector? Yes, the first displacement vector is AB vector. Then AB equals vector B minus vector A. Vector B minus vector A equals 5, 3 minus 2, 4. Then the first displacement AB equals the ordered pair 3 and negative 1. Now, what is the work done during the first displacement? W equal F dot S, vector F dot vector S. Then W equals 3 and 5 dot 3 and negative 1. Then W equals the first component 3 times the first component 3 plus the second component multiplied the second component 5 multiply negative 1. Then the work W equals 9 plus negative 5, which equals 4 work unit. Now, what about the second displacement vector BC? BC vector equal C vector minus B vector, which equals 8 comma negative 2 minus 5 comma 3. Then the vector BC equals 3 and negative 5. Then the work done during the second displacement BC is W equals vector F dot vector S. W equals 3 comma 5 dot 3 comma negative 5. Then the work equals the product of the first component of the vector F multiply the first component of the vector S. 3 multiply 3 plus the product of the second component of the vector F multiply the second component of the vector S, which is 5 multiply negative 5. Then W equals 9 plus negative 25, and the work in this case equals negative 16 work unit. Now we can calculate the resultant work. The resultant work equal sum of two works. W equals W1 plus W2, then W equals 4 minus 16. Then the resultant work W equals negative 12 work unit. Now what about the resultant displacement vector AC? AC vector equals vector C minus vector A. Vector C 8 comma negative 2 minus vector A 2 comma 4. Then vector C equals 6 comma negative 6. What about the work done during the resultant displacement AC? W equals F dot S. Vector F dot vector S. Vector F, the force acting on the body, 3 comma 5 dot the displacement AC, which is 6 comma negative 6. Then W equals 6 multiply 3 plus 5 multiply negative 6. Then W equals 3 times 6 equals 18 plus 5 multiply negative 6 equal negative 30. Then the work in this case equals negative 12 work unit. This value equals the resultant work by the sum of the two works W1 plus W2. Another example, the force F equals 2I plus 3J. Vector F equals 2 in the positive direction of x-axis plus 3 unit in the positive direction of y-axis. This force acts on a particle and the position vector at a moment t is given by the relation x vector equals 2 plus 5 between two brackets in the positive direction of x-axis, or t plus 5i plus t power 2 plus 4 in the positive direction of y-axis, or t power 2 plus 4 in direction j, where I and j are the fundamental unit vectors and I and j in the positive direction of x-axis and y-axis. Calculate the work done by this force from t equal 1 to t equals 5. Now we have the position vector x, but what is the displacement vector occurring from t equals 1 to t equals 5? We know that s equal x minus x node, or x at t equals 5 minus x at t equals 1. The position vector x is a function in time. Then the displacement s is a function in time. Then s equals 5 plus 5 I plus 5 power 2 plus 4 j. minus 1 plus 5i plus 1 power 2 plus 4j. Then the displacement vector S equals 10i plus 29j, which is x at t equals 5, minus 6i plus 5j, which is the position vector x when t equals 1 second. Then the displacement vector S equals 4i plus 24j. Now the work W equals vector F dot vector S. W equals 2, 3 dot 4, 24. Then the work equals 2 multiply 4 plus 3 multiply 24. Then W equals 8 plus 72. Then W equals 80 work unit. Now, dear student, what is the unit of measure of work? We know that the work W equals vector F dot vector S. Then unit of measure of W equals unit of measure of force multiply unit of measure of length. Then joule equals Newton times meter. Joule is the unit of measuring of the work, and the Newton for the force, and meter for the displacement S. And if the force in dyne and the displacement in centimeter, then the work W in erg. Now, what is the meaning of the joule? The definition of the joule: it is the magnitude of the work done by a force of magnitude 1 Newton in moving a body a distance 1 meter in the direction of the line of action of the force. Then the joule is the magnitude of the work. But the force must be in Newton and the displacement must be in meter. And the erg is the magnitude of the work done by a force of magnitude 1 dyne in moving a body a distance 1 centimeter in the direction of the line of action of the force. Then 1 joule equals 10 power 7 erg, and 1 kilogram weight times meter equals 9.8 Newton meter. Then 1 kilogram weight times meter equals 9.8 joule. We know that Newton meter equals joule. Then 1 kilogram weight times meter equals 9.8 Newton meter, or equals 9.8 joule. And 1 gram weight times centimeter equals 980 dyne centimeter. And we know that dyne centimeter is equal to erg. Then 1 kilogram weight times centimeter equals 980 erg. Now, if the force vector parallel to the displacement vector, then what is the work in this case? If the force vector is parallel to the displacement vector, then the work done by this force is equal to the product of their algebraic measure. Then W equals F times S. But we have the 3 cases for the directions of F and S. The first case, if the force vector F and the displacement vector S in the same direction and in the same direction of the unit vector E. In this case, the work must be positive. And if the 2 vectors F and S in the same direction but in the opposite direction of the unit vector E, in this case the work is positive magnitude, because F and S have the same sign negative sign, then the product of f and s in this case is positive. But the third case, if the two vectors, displacement vector and force vector in two opposite direction, s in the direction of E and f in the opposite direction of E, then the product of vector f and vector s in this case equals negative. Then the work positive if the two vectors f and s have the same direction, positive or negative. In case of the two vectors f and s have two different directions, then the work in this case equals negative. Now another example. A body moves on a straight line. A resistance force of magnitude 100 Newton acts on it. Calculate the work done by this force during a displacement of magnitude 300 meter. Now, S equals S in the positive direction of the unit vector E, and vector F equals negative FE in the opposite direction of the vector E. Now, since the force is a force of resistance, then it acts in an opposite direction to the displacement vector. And if vector E is a unit vector in the direction of the displacement vector, then the displacement vector in this case is positive. And we can express the force vector in the opposite direction of the vector, unit vector E, then F in this case must be negative FE. Then the work in this case equals negative S times S. Work equals negative 100 Newton multiply 300 meter. Newton meter negative 30,000 Newton meter. Newton meter equals joule. Then the work in this case equals negative 3 multiply 10 power 4 joule. Joule equals Newton meter. Another example. The opposite figure shows the action of a variable force F on a body. Calculate the work done in erg by this force in the following cases. The first case, when the body moves from S equals 0 to S equals 8. The second case, when the body moves from S equals 8 to S equals 12. And the third case, when the body moves from S equals 0 to S equals 12. We know that the work W equals integration F ds from A to B. In the first case, when the body moves from S equals 0 to S equals 8, then the work done W1 equals integration F ds from 0 to 8. We can calculate the work by definite integral of the force F with respect to the variable S, or with respect to the displacement. And we know that the integration of F ds from 0 to 8 equals the area under the curve from S equals 0 to S equals 8. Then W1 equals the area of the triangle OAB, which equals half times base times height. Half times base, which equals 8, multiply the height 12. Then the work in this case equals 48 joule. And you can calculate the work done from S equals 8 to S equals 12 in the same way by the area of the triangle BCD, but in this case the triangle BCD lies below the x-axis, then the integration equals negative area of triangle BCD, which equals negative half times 4 times 6. Then the work in this case equals negative 12 joule. In the third case, S from 0 to 8, then the work equals the area under the curve from S equals 0 to S equals 12, which equals the area of triangle OAB minus area of triangle BCD equals 36 joule. Another example, a variable force F measured in Newton acts upon a body where F equals 3s per 2 minus 4. Find the work done by this force in the interval from S equals 2 meter to S equals 5 meter. Now we have a relation between F and S, the function F or the variable force F in terms of the displacement S. Then we can calculate the work as W equals integration F ds from A to B. Then W equals integration 3s per 2 minus 4 ds from A to B or from 2 to 5. The integration of 3s per 2 equals s per 3 minus the integration of 4 is 4s from 2 to 5. Then the work equals 5 power 3 minus 4 times 5. When we substitute about s equals 5 minus when s equals 2, then 2 power 3 minus 4 times 2, the work W equals 125 minus 20 minus 8 minus 8. Then the work equals 105 جول. بكده اعزائي نكون استعرضنا مع بعض موضوع الورك، وعرفنا لما يكون عندي بادي بيتحرك displacement from A to B نقدر نحسب الديسبليسمنت دي، وعندي الفورس اللي حركت البادي، يبقى الفورس بتاعتي لو هي فيكتور والديسبليسمنت فيكتور اقدر اجيب السكالر برودكت بين الاثنين دول اوصل للورك ايكوالز كام. وخلي بالك ان الورك هنا سكالر كوانتيتي بيطلع بوزيتيف يطلع نيجاتيف يطلع زيرو حسب طبعا الماجنتيود والدايركشن بتاع الاف والاس، نقدر نحدد على طول الورك. كمان عرفنا اليونتس اللي هنستخدمها لما نشتغل على الورك، وعرفنا ان هي جول او ارج، وعرفنا ان الجول ايكوال 10 باور 7 ارج. كمان عرفنا ان الجول هي نيوتن متر والارج هي داين سنتيمتر. عرفنا نحسب الورك لو عندي جراف رسم لي الجراف، وقلنا قبل كده ان الجراف دي تبقى غنيه بالمعلومات. لو عرفت احسب الاريا اندر ذا كيرف يبقى انا عرفت احسب على طول الورك، بس لازم اخد بالي ان الريليشن هنا الاكس اكسس هي الديسبليسمنت والواي اكسس هي الفورس، عشان تبقى دايما الفورس ان ترمز اوف اس. او لو عندي ريليشن صريحه بين اف اند اس اقدر اعمل انتجريشن ديفينيت انتجرال احسب منها الورك during displacement معينه هو هيديها لي. Dear students of grade 3 secondary, by this example we come to the end of our program today. Until we meet again, it's goodbye.